going on page 78 when we're done, but we're actually going to start on the other side of the paper. So I want you to flip it over and go to the circle right here, and I want you to fill in the angle measures in radians, starting with 0, 2 pi, pi 6, and those little lines there, they're fraction bars, and just fill in your angle measures all the way around the circle and then stop. Okay, are we good? Remember the patterns and how to get there? That if I need 5 pi 6, I'm here 6 pi 6, back up 1 to get there, go forward 1 to get there, right? Okay, so now we're going to fill in the ordered pairs just for the quadrantals. So at 0, what is my ordered pair? 1, 0, good. And then pi halves? 0, 1, good. Pi? Good. 3 pi halves? 0, negative 1. Very good. Okay. And we remember that in these ordered pairs, the x value represents what? Cosine. And the y value represents sine. Very good. All right. So go ahead and get these 3 ordered pairs in the first quadrant written in. Okay, do these 3. So do y'all agree with those? Got those? Use the hand trick if necessary, absolutely. So we know in the first quadrant, all of the trig functions are positive. In the second quadrant, which one's positive? Sine. In the third quadrant, which one? Tangent. Fourth quadrant? Cosine. All students take calculus, right? So knowing that and having our first quadrant correct, fill in the rest of your ordered pairs. it all coming back to you now? Putting it at the forefront of your brain here. Yes. Okay, so let's do the tangent values just for the quadrantals. What is the tangent of 0? 0. What is the tangent of pi halves? Undefined. What is the tangent of pi? 0. And 3 pi halves? Undefined. Good. Because 0 over 1 puts 0 in the numerator, which makes it 0. Negative 1 over 0 puts 0 in the denominator, which makes it undefined, right? Okay, so do your tangent values for these three. These three in here. So remember, pi 6 takes 2 3s to get a 6, so we got 2 3s in there, 1 3 there. Now, let me ask you a question not related to trig values at all, so don't like overthink it and think I'm asking about one of these values. Just remember, these are reciprocals of each other, right? If I put 1 over the square root of 3 and rationalize it, I get this, right? So these are reciprocals of each other. So if the reciprocal of the square root of 3 over 3 is the square root of 3, then what's the reciprocal of the square root of 2 over 2? Think about that. Reciprocal of square root of 3 over 3 is square root of 3. Reciprocal of square root of 2 over 2 would be square root of 2. Make sense? The reciprocal of square root of 5 over 5 would be the square root of 5. The reciprocal of the square root of a monkey over a monkey would be the square root of a monkey. Like, it doesn't matter what it is, it's the same pattern, okay? Because just put that in your brain too. Hold on to that, put a pin in it for a minute. All right, so now that we've got these correct, fill in the rest of your tangent values. Okay, so this is all the stuff we knew and learned to love before Christmas, right? All this stuff is stored in your brain. Make sure you know how to access it accurately and efficiently, right? Any questions at all about any of this? Okay, and if you stare at it long enough, you'll see other patterns. You can think of other ways to think about it. Whatever makes sense to you is fine. Doesn't have to be the way it's coming out of my brain. I'm just giving you ways to think about things. All right, so now we're going to pause on that side, go to the other side while I go answer my phone. So we did a lesson very similar to this before Christmas, but it only had sine, cosine, and tangent. So now we're looking at the reciprocal functions. On these first four, oh, I'm sorry. Oh, someone at the door. Hello. Okay, thanks. On these first four, I'm going to have you write down more stuff than you necessarily have to write down when you do it on all the rest, but I do want you to actually write them all down on 1 through 4 because it's the thought process. And after a while, it's all just going to be in your head. You're going to think through it quickly, but you know, if you forget what you're supposed to do, this kind of shows the steps, right? So when we're talking the reciprocal functions, right, we want the cosecant. Here's the thought process. Now, if you just ask me cosecant, secant, or cotangent of a value, that's not something that just comes directly out of my mind. I think through sine, cosine, and tangent for all of them. It's what most everybody does. I mean, some people have the kind of brain where they just memorize everything separately, whatever. But that's not something that's really expected or how it's normally done. So I have cosecant of 2 pi thirds. So the first thing I think is, what is the reciprocal of cosecant? Sine. Okay, so again, we're going to write this down. We're not always going to have to write all this, but I want you to write out sine. And then 2 pi thirds. Which quadrant is that in? Second quadrant, okay? And then I ask myself, in the second quadrant, is sine positive or negative? Positive, okay? So then after all that, I'm just using the reference angle. What's the reference angle for 2 pi thirds? Pi thirds, right? That's when I can refer to a hand trick, right? Here's pi. So remember, this is 0, pi 6, pi 4, pi thirds, pi halves. So here's pi thirds. I want the sine of pi thirds. The sine of pi thirds is square root of 3 over 2, right? But I want the reciprocal, so that becomes 2 over the square root of 3. Now, on these first four, we're going to actually go through the math, but that's not something I want you to have to do every time. You're going to just know them, and I'll show you why in just a second. Can't leave it like that, so I rationalize, right? When I do, I get 2 square roots of 3 over 3, and it's positive. That's my answer. Okay? So there's little steps you have to think through to make sure you've thought of everything before you give an answer. Okay? We good on that? Any questions? All right, so on number 2, secant. What is the reciprocal of secant? Cosine. 5 pi fourths, so it's cosine. And then 5 pi fourths is in which quadrant? Third. In the third quadrant, is cosine positive or negative? Negative. Okay? Everybody agree with all that? So then my reference angle is pi fourths. The cosine of pi fourths is square root of 2 over 2. Okay? So that means the secant would be 2 over the square root of 2. And then we rationalize. And when you rationalize this one, you get 2 square roots of 2 over 2. But that just gives you square root of 2, and it's supposed to be negative square root of 2. But again, we shouldn't have to do that because we should know if the reciprocal of the square root of 3 over 3 is the square root of 3, the reciprocal of the square root of 2 over 2 is the square root of 2. But again, we're writing that down because if all else fails, at least you know how to find it. If you just can't remember anything because your brain hurts and you're freaking out or whatever, you can actually get there. Okay? Are we good? All right. Cotangent is the reciprocal of tangent. Okay, so tangent, 11 pi 6 is in which quadrant? The fourth. And in the fourth quadrant, is tangent positive or negative? Negative. Okay. So then we go to pi sixths. What is the tangent of pi sixths? Square root of 3 over 3. So that makes it 3 over the square root of 3, right? Which really becomes what? Square root of 3. Okay, so if we had to, we could do this, which becomes, actually I shouldn't have written that yet. I'm going to run out of it. Which becomes 3 square roots of 3 over 3. And then isn't it just much easier just to remember that it's the square root of 3 and understand the pattern? Yeah, you don't want to have to go through that every time. Because I see students when I'm asking you that, they're not writing it down, but they're doing the rationalizing in their brain, which it's not wrong. It's just if you take a second to see how it works, you don't have to do that every time. All right, cosecant is the reciprocal of sine, right? Negative 2 pi thirds is in which quadrant? The third, okay? Then the third, because we got to go clockwise. And in the third quadrant, is sine positive or negative? Negative. Now, and remember, this negative and this negative, completely unrelated. Like that it's not, this isn't negative just because this is. It has to do with what quadrant you're in. All right, so then pi thirds. The sine of pi thirds is? Sine is square root of 3 over 2, right? We understand how the hand trick works. Square root of 3 over 2, which means cosecant is 2 over the square root of 3. And we already figured that out over here, so that becomes negative 2 square roots of 3 over 3. So I want you to look at, no, we'll look at that differently in just a second. Okay, any questions at this point? All right, so let's look at our quadrantals then. If we're at 0, okay, so this could be 0 or 2 pi or 4 pi or negative 2 pi, whatever gets me there. And we're going to find the cosecant of 0. Cosecant is the reciprocal of sine. What is the sine of 0? 0, which means when the cosecant is the reciprocal, what's the cosecant of 0? Undefined. Thank you. Thank you for not saying 0. All right, and then the secant of 0. Secant is the reciprocal of cosine. The cosine of 0 is 1. The reciprocal of 1 is 1. Is this 1 over 1? This one. I know, I get 1/2 all the time. Don't know where it's coming from, but I get it all the time. Then cotangent of 0. So what's the tangent of 0? 0. So that means that the cotangent is undefined. All right, so let's look at pi halves. Cosecant of pi halves. Cosecant is the reciprocal of sine. The sine of pi halves is 1, so the cosecant is 1. Then secant of pi halves, secant is the reciprocal of cosine. The cosine of pi halves is 0, so the secant is undefined. Okay, so the tangent of pi halves, oh, not cotangent, I'm sorry, cotangent. That's not what I'm doing there. The cotangent of pi halves, that is the reciprocal of tangent. The tangent of pi halves is undefined, so what do you think the cotangent is? It's 0. Okay, so here's where, and we're going to talk about this twice because wording matters. Now, I can say the reciprocal of 1 is 1. I can say the reciprocal of 0 is undefined. Those are true statements. I cannot say that the reciprocal of undefined is 0 because you can't take the reciprocal of something that's not even defined. Does that make sense? That doesn't mean we can't answer this question. That means we don't just think of it as taking the reciprocal of this value. But if we think of it as taking the reciprocal of tangent, when we got this undefined, it was because we put 1 over 0. The reciprocal of that is 0 over 1, and that's why we get this 0 here. Okay? Does that make sense? Wording matters, and again, we'll talk about that a little bit again in another part in here. All right, so then let's look at pi. So I want cosecant of pi. Cosecant is the reciprocal of sine. The sine of pi is 0, so the cosecant is undefined. Then the secant of pi. Secant is the reciprocal of cosine. Cosine of pi is -1. The reciprocal of -1 is -1. Because we put 1 over -1, and that becomes -1. See, it's the easy things that are the hardest, right? All right, then the cotangent of pi. So the tangent of pi is 0, so the cotangent is undefined. All right. Now we're on to 3 pi halves. And I don't know what happened here. I moved things around, and apparently I forgot that guy, but he belongs on the axis, so you can kind of ignore the other one. So cosecant of 3 pi halves. So cosecant is the reciprocal of sine. The sine of 3 pi halves is -1. Think about where you are, 0, -1, right? -1. So then if the sine is -1, the reciprocal of -1 is -1. Then the secant of 3 pi halves, that's the reciprocal of cosine. Cosine of 3 pi halves is 0, so that means the secant is undefined. Then cotangent of 3 pi halves. The tangent of 3 pi halves is undefined, which means the cotangent is 0. Okay? We good with that? So let's talk about that for a minute, because wording matters, like I said. And I told you yesterday when we talked about statistics, there's a lot of writing to explain yourself, and you got to make sure when you explain yourself, you're using the correct wording, and you're actually saying what you're trying to say. You have to do the same thing in calculus. It's not as wordy and paragraph-wise, but you still have to make sure you're using the right words, even if it's just like 5 words. So like I said, I couldn't say that the cotangent of 3 pi halves is 0 because the reciprocal of undefined is 0, because that's a false statement. But I can say, since the cotangent of pi is undefined, the tangent of, I don't know why I'm pointing to that. Let me back up. I can't say that the tangent of 3 pi halves is undefined, therefore the cotangent is 0. I can say it that way, but I can't say because it's the reciprocal of undefined. Does that make sense? Like that's, you have to make sure that this is a true statement. It's 0, but not because it's the reciprocal of undefined. It's because it's the reciprocal of tangent. And you just have to be careful with your wording there. I think I made it worse because I got my words all mixed up. But. All right, so let's try some of these. We're going to do some together, and then I'm going to have you do some on your own. And we're not necessarily going to write down as much. You can write down whatever you want, but I'm just going to show you don't have to, but you have to think through it. Sometimes I write down at least something, or I'm going to forget what I just thought. All right, so the reciprocal of cosine is what? Oh, cosine, I'm sorry. Yeah, no wonder you're not answering because I'm asking a weird question. The reciprocal of cosecant is sine, 3 pi fourths is in which quadrant? Second. And the second quadrant is sign positive or negative? Positive. So I usually at least write that down so I don't forget to take care of the sign at the end once I think through it. So then I want to think the sign of pi fourths is what? Square root of 2 over 2. And the reciprocal of the square root of 2 over 2 is square root of 2, right? Then it's just positive, so that's my answer. Secant is the reciprocal of cosine. What quadrant is pi in? It's a quadrantal, so it's not, so I don't have to worry about this. The sign just is going to come naturally. So what is the cosine of pi? Negative 1, and the reciprocal of negative 1 is? Negative 1. Okay, good. All right, then cotangent is the reciprocal of tangent. Negative 5 pi thirds is in which quadrant? I got all of them before. It's the first, okay? Because this would be 3 pi thirds, 4 pi thirds, 5 pi thirds if I go that way. So we're in the first quadrant, which means it's positive. All right, so then the tangent of pi thirds is square root of 3. So the cotangent is square root of 3 over 3. All right, so then we got cosecant. That's the reciprocal of sine. 2 pi thirds is in the second quadrant, so the value is positive. Sine of pi thirds is square root of 3 over 2, so the reciprocal is 2 square roots of 3 over 3. Okay? So let me show you something here off to the side as far as reciprocals go. So if I have, we know if we take the reciprocal of the square root of 3, that becomes 1 over the square root of 3, and that gives me square root of 3 over 3, right? If I have 1 over the square root of 2, that becomes square root of 2 over 2, right? Well, when we take the reciprocal of the square root of 3 over 2, we get 2 over the square root of 3, right? That's not that much difference than this, is it? It's just 2 times that. So we still get our square root of 3. Our square root of 3 still becomes square root of 3 over 3. We just have this 2 in front of it. You see how that works? This is really the only one that you're going to have to know. These hopefully should kind of come naturally. This one looks a little weirder because things don't like cancel out or whatever if you go the other way. But that's all that's happening there, just like the 2 got factored out. Okay? All right, so let's look at number 9. Cotangent's the reciprocal of tangent. 3 pi halves is in which quadrant? It's a quadrantal. So what is the tangent of 3 pi halves? Undefined. So the cotangent is 0. Good job. All right, secant is the reciprocal of cosine. Negative 5 pi sixths is in third, because it's negative, right? If I start here, this is negative 6 pi 6, I back up 1. Negative 5 pi 6 would be the third quadrant. So in the third quadrant, is cosine positive or negative? Negative, okay? And then the cosine of pi sixths is what? Square root of 3 over 2. So this becomes negative 2 square root of 3 over 3. Oops. Okay. What questions you got? All right, I'm going to give you a couple minutes, and I want you to do 11, 12, and 13, and then stop. Yes. Okay, that should be more than enough time. Let's see who's going to help me with these. All right, Erin, you're going to help me with number 11. So secant is the reciprocal of what? Oh, Erin. Cosine. And 3 pi forces in which quadrant? 2. So is it going to be positive or negative? Negative. What is the cosine of pi fourths? Okay, which means your final answer is negative square root of 2. Yes, good job. All right, y'all agree with that? Any questions? All right. Shaylin, can you help me with number 12? Cotangent is a reciprocal of? Tangent. 2 pi thirds is in second quadrant. So is it positive or negative? Negative. What is the tangent of pi thirds? Square root of 3. So that means our final answer is? And we make sure we make it negative. Good. Negative square root of 3 over 3. You got it. Good job. Thank you. All right, Gabby. Cotangent is the reciprocal of tangent. Pi halves is in the, it's quadrantal. Good. So then what is the tangent of pi halves? It's undefined, so cotangent is 0. Good. All right. Any questions on those? All right, do the last 3. Give you a couple minutes for that. Okay, good. Okay, let's see who's going to help me with these. Erzeth. Secant is the reciprocal of cosine. Negative pi fourths is in which quadrant? It's negative, so we're going to have to go this way. So it's in the fourth. So in the fourth quadrant, is cosine positive or negative? Positive, okay. And then what is the cosine of pi fourths? Square root of 2 over 2. So that means the secant is, what's the reciprocal of the square root of 2 over 2? It's just square root of 2. Okay. All right, good deal. Next one, Alejandro. Cotangent is the reciprocal of tangent. 5 pi fourths is in the, so the value is positive or negative? Positive. All right, so what is the tangent of pi fourths? 1, so the cotangent is? Seems too easy, right? I know, y'all want to overthink everything. All right, good deal. Last one, Holly. Cosine. We don't have to think about a reciprocal, right? What quadrant is negative 5 pi 6 in? I'm going to go negative. It's in the third because this will be negative 6 pi. So it's in the third quadrant. So is this going to be positive or negative? Negative. So what is the cosine of pi 6ths? Square root of 3 over 2. So that means my answer is just negative square root of 3 over 2. Okay? Don't have to think about reciprocals. Good deal. All right. Any questions at all? All right. Flip it back over. Go up to the top this time. So we're going to fill in our sine column, right? So the sine of 0 is what? 0. The sine of pi halves is 1. The sine of pi is 0. The sine of 3 pi halves, negative 1. All right. The sine of pi 6 is 1/2. Pi 4ths, square root of 2 over 2. Pi 3rds, square root of 3 over 2. Okay? We're all good with that, right? Okay, skip the cosecant column, go to the cosine column. So make sure you skip that one. We're here. The cosine of 0 is 1. Pi halves, 0. Pi, negative 1. 3 pi halves, 0. Good. Cosine of pi 6, square root of 3 over 2. Good. Pi 4ths, square root of 2 over 2. Pi 3rds, 1/2. So one of the things we looked at when we filled out a similar table last semester was it's all the same numbers. These just flipped around and, we're just using the same thing over and over again, right? So skip the secant column and let's go to the tangent column. What is the tangent of 0? 0. The pi halves? Undefined. Pi? 0. 3 pi halves? Undefined. Okay. Pi 6ths? Square root of 3 over 3. Pi 4ths? 1. Pi 3rds? Square root of 3. Okay. So those should all be solidified in your brain. We did those last semester, right? And we talked about reciprocals, but we didn't really talk a whole lot about their values and stuff like we are today. So let's go back to our cosecant column. So these values are basically all the reciprocals. Well, not basically. They are all the reciprocals of these values because cosecant is the reciprocal of sine. So if the sine of 0 is 0, what's the cosecant? What's the reciprocal of 0? Undefined. Because the reciprocal of it, if it's a fraction, you just flip it over. If it's not a fraction, you put 1 over whatever it is. What's the reciprocal of 1? 1. So what would be the cosecant of pi? Undefined. What about 3 pi halves? Negative 1. Okay. What's the reciprocal of 1/2? 2. What's the reciprocal of the square root of 2 over 2? Square root of 2. What's the reciprocal of the square root of 3 over 2? Good. 2 square root of 3 over 3. Yeah. The only things that are over 2 are your sine and cosine values. So secant is going to be the reciprocal of all the cosines. So the secant of 0 has to be 1. Secant of 0 is, secant of pi halves is undefined. Secant of pi is negative 1. 3 pi halves, undefined. The reciprocal of the square root of 3 over 2 is 2 square root of 3 over 3. Reciprocal of the square root of 2 over 2, square root of 2. The reciprocal of 1/2, 2. Okay, so let's just look at these purple values right now. So these, I think, hopefully at least, are pretty simple to reason through once you don't try and do weird things with reciprocals. These we're using the same numbers over and over again once again. These reciprocals, no big deal. This is really the only new one that might be kind of tricky, But just remember that, first of all, if it was 2 square root of 3 over 2, like I heard, which is fine because I know it's still new, the 2's would cancel out. You'd be left with the square root of 3. So it wouldn't make sense to have a fraction like that. And again, the only things that are over 2 are your sine and cosine values. Anything else that's a fraction is going to be over 3. All right, so let's look at cotangent. So the reciprocal of 0 is undefined. Okay, so let me see if...
If you have not taken your attendance, please do so. Thank you.
So let's talk wording again, see if I can get the words out of my mouth correctly. I cannot say that the reciprocal of undefined is 0, like if I was to write things out. That is not a true statement. But I can say, since the tangent of pi halves is undefined, the cotangent value is 0. So it's a true statement that the answer is 0. You just have to be careful about what you're saying is true. All right, so which means the cotangent of pi is undefined. 3 pi halves would be what? 0. Then what's the reciprocal of the square root of 3 over 3? Square root of 3. Reciprocal of 1? 1. Reciprocal of the square root of 3? Square root of 3 over 3. So remember, one of the things we looked at was that how the sine and cosine values for pi thirds and pi sixths switch places. Well, that's what happens with your tangent and cotangent values as well. Okay. So when you fold this and tape it in, this should be what's prominently displayed there. I don't want you to use it to always refer to pick your answers off of, but I do want you to see the patterns. It's there to check yourself, but you've got to try and get this stuff out of your brain without help. Okay, we good? Any questions?